In this video, we present the results of our work on predicting congenital conditions from facial features. The World Health Organization defines a congenital disorder as a condition that is present before or at birth. Genetic testing is used to detect these conditions. However, many of these can also be recognized by distinctive facial features. Tools to assist with predicting these conditions are therefore required since, firstly, early interventions are key for improving a child's quality of life, and secondly, due to the number of conditions and its rarity, it is often challenging for doctors to accurately diagnose these conditions. Detailed discussions with our partner in the morphology research group produced the following 3 project goals. Firstly, to build a classifier that can distinguish between persons with and without a potential syndrome that can be used as a screening tool. Secondly, to build and train a classifier to predict a Caucasian image as non-syndromic, Noonan syndrome, or Mowat-Wilson syndrome. And lastly, due to very little research being done in the African population, it is required to validate the usefulness of this classifier on African images. The morphology research group uses J-psychomorph software to manually delineate images to obtain XY coordinates of facial features. The problem with this approach is that it is resource intensive. They also showed that a logistic regression model performed best and achieved prediction metrics such as accuracy and sensitivity all greater than 90%. This is our proposed approach to predicting congenital conditions. The first step is an initial screening tool through implementing an anomaly detector. It is non-syndrome specific and highlights the possibility of a syndrome being present. This can then justify further diagnosis. For syndrome-specific predictions, we implemented 2 approaches, namely automated delineation of facial features and computer vision. Currently, both methods evaluate Mowat-Wilson and Noonan syndrome as separate models. It provides a probability of a prediction and is used in combination with the initial screening result. Face detection and cropping is a necessary image pre-processing step prior to training of the various models. However, it was found that face detection on African images were less successful and needs further investigation. The autoencoder is trained on non-syndromic images and comprises a 2-step process in which it first compresses the image and then reconstructs the image. The density distribution of the compressed images and the distribution of the reconstruction errors are 2 measures used to detect anomalies. This graph on the right shows the density distributions for non-syndromic images for training and validation. When the model is presented with syndrome images, the distribution shifts, and this segregation is the premise for anomaly detection. Automated detection of facial features are performed on the cropped images. During this process, images are resized and rotated, after which the standardized coordinates are used in the logistic regression model. The last approach was computer vision using a convolutional neural network. On the right is an activation map of one of the neural network layers. It shows that the image is indeed being recognized. One also notices the detection of contrast due to lighting. On this next map, the edges of the face can be noticed. And on this last map, the lighter areas correspond to the detection of the eyes and mouth. The results of the 3 approaches are summarized as follows. As can be seen, automated delineation of facial features and computer vision techniques both prove to be viable options to replace manual interventions. Computer vision approaches, however, showed to be more accurate and more predictable. These results are preliminary and models require refinement to improve overall predictability and stability. It is recommended to expand the models to multi-class classifiers, to obtain more training images, and to understand and solve the face detection problem on African images. Thank you for listening and have a great day.